We're working on Unit 5, which is our unit on systems. This is our 5th day, so we're going to continue looking at systems of inequalities. This time we're going to move into word problems and solving word problems that involve inequality systems. But as a warm-up, just to remind us of how we work with just inequality systems that are given to us straight away, we're going to graph our boundary lines and then shade using a test point, and see where we have an overlapping shaded area. So y is less than -3. I know that's a special case line. It's a HOI. It's a horizontal line, right? So I'm going to, any place I have y is -3. It doesn't matter what x is. Y is going to be -3, right? So this is y is less than -3. That means I'm going to have a dashed line here. Okay, and now I have to decide with a test point whether I'm going to shade above it or below it. I like the test point 0, 0, so that's what I'm going to test with, 0, 0. If I plug in 0 for y, I get 0 is less than -3, and that's not true, right? That is wrong, and so that means I'm not going to shade 0, 0. I'm going to shade instead the other direction. All right, so that's my shading for my HOI line. Okay, the boundary is here, and I'm shading the inequalities down below it. My next line, y is greater than or equal to 4x plus 1/2. I am going to graph that boundary line. This one's going to be a solid line and not a dashed line. And I'm going to start at the y-intercept of 1/2, and I'm going to go up 4. 1, 2, 3, 4, and over 1. I'm going to back myself down 1, 2, 3, 4, and over 1. So this is going to be a a solid line right there, and I'm going to figure out a test point. Well, 0, 0 is not on my line, so I'm going to check that 0, 0 here as well. 0 is greater than 0 plus 1/2. That's what I get, greater than or equal to 1/2. That's not true, so that means that 0, 0 is not part of my solution. So instead, I'm going to shade the other side. And we know that our solution to this system is any place that we have overlap. So that's our solution right there. Okay, let's look at the next bit of information. In order to graph, I want to see this in slope-intercept form. So I'm going to rewrite that. That'll be y is less than or equal to x plus 3. Okay, and I'm going to rewrite my other inequality statement. That's going to be 2y is less than or equal to -x plus 8. I haven't got y alone, so I'm going to divide everything by 2. Y is less than or equal to -1/2 x plus 4. All right, and so now I'm going to graph. This first one is going to start at 3, and it looks like my slope is 1 over 1. So I'm going to go up 1 over 1. Okay, y is less than or equal to x plus 3 is going to be a solid line because I get the equal sign in there too. So solid line. So for my test point, I'm going to go back to the original inequality statement. So I'm going to test with 0, 0. I'm going to plug that in. So I have 0 minus 0 is less than or equal to 3. 0 is less than or equal to 3. That's true. So that means 0, 0 is a possible solution here. So I'm going to shade and include 0, 0. Okay. The next inequality statement that I have to start by plotting at 4. And this is going to go down 1 over 2. So I'll go backwards. All right, this is also a solid line because I have less than or equal to. So I'm going to make that a solid line. And of course I'm going to use my test point, but go back to your original inequality statement. So if I test 0, 0, I'm going to get 0 plus 0 is less than or equal to 8. And that's true. So I get to include 0, 0 for that information too. So when I shade all on the lower side of that line, I can see that I'm overlapping all in this wedge. All right, so that's just a quick reminder of how we graph our system of inequalities to find the solutions. Today's notes are going to be all about word problems that have systems of inequalities. So we just want to think about some words that are going to give us the symbols that we're using. So if I use the phrase less than, just plain less than, I have to show that the thing on the left is less than the thing on the right. I might say fewer than. It kind of depends on what items I'm talking about. Fewer than. I might say, if this is less than or equal to, things that I might say no more than. Okay, so if I have no more than 5 cookies, I could actually have 5 cookies, right? I just can't have more. I can't have 5.5 cookies. So other phrases I might say, I have at most 5 cookies. I can have 5, I just can't have 5.5. I might say a maximum of 5 cookies. And I might say the number of cookies I have is not greater than 5. Okay, it could be 5, it just can't be more than 5. If I say the number of cookies I have is fewer than 5, I can't have 5 cookies. I can have 4.5, I just can't have 5. Okay, so in the same way, we're going to think about greater than. We might say greater than with this symbol, or we might say more than. We might say exceeds. Oops, exceeds has 2 E's. So the number of cookies I have exceeds 5. Okay, so it has to be more than 5. It can't actually be 5. All right. Over here, I might have no less than, and of course that's the same as no fewer than. I might say at least, or a minimum of. I have a minimum of $20, and that means that I can go to the movies and maybe buy the smallest box of popcorn, depending on how much the movie costs. Okay, I might have not less than. So those are all phrases that mean that you could actually equal a specific number. You just can't go below it. All right, so we're going to look at this first word problem. Sarah's pet store never has more than a combined total of 16 cats and dogs. She also never has more than 9 cats. So we've got some negatives in here. This is going to be a little tough, but we're going to try to work through it, okay? We need to define our variables, just like we did with word problems for equations, systems of equations. So I'm going to say X is my cats, and I'm going to say Y is my dogs, because we're talking about her pet store with cats and dogs. So she talks about her combined total of cats and dogs. So cats plus dogs. We know the number that we're going to talk about is 16. So now we have to decide. She never has more than a combined total of 16 cats and dogs. So she doesn't get to have more than 16, right? Can't be more than 16. It could be equal to 16, so I could say equals right here, but it can't be more than, so it has to be less than 16 or equal to 16. With this extra negative, it's a little bit weird. She never has more than 16. Okay, so if that's true, then she will always have less than or equal to 16. The other information I have is just about her cats. Cats, we're calling X, and we have some information, something to do with 9 cats. She never has more than 9 cats. She never has more than 9 cats. So she has to have less than, fewer than 9 cats. But can she actually have 9 cats? Yeah, she can. It can be equal to 9, because 9 isn't more than 9, it's just exactly 9. So if these are our 2 pieces of information, then I know this is dogs here, and this is cats here. I'm going to need to plot these 2 boundary lines. Okay, so this top line, we're going to make that one the blue one. In slope-intercept form, it looks like this. Y is less than or equal to negative x plus 16. The bottom line is a Vux line, right? That's a vertical line. And so I know that, as it says, x is less than or equal to 9. It's going to be a vertical line. So looking at this graph, it looks like I can't do 1, 2, 3, 4. I can't get all the way to 16. So I'm going to go by 2s. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. Okay. I'm gonna say cats, I can go by ones. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. But be careful, because if you have different scales vertically compared to horizontally, you just really need to be careful when you're drawing your graph. So we're really gonna have to think this through, okay? If y is less than or equal to negative x plus 16, I'm gonna start at 16. And then I'm gonna come down 1 over 1. So down 1, 16 minus 1 is 15. Down 1 over 1. I'm stuck in the middle there. Down 1 over 1. Down 1 over 1. So just be really careful. It's because we are going by 2's vertically here. So I can see what direction that line is going to go. This is less than or equal to, and so I know that I can do a solid line. Okay, so that's going to be a solid line going like that. And then I'm going to have to figure out, am I shading above it or below it? So let's try a test point. Test 0, 0. I'm going to go up to the original inequality statement I wrote. 0 plus 0 is less than or equal to 16. 0 is less than or equal to 16. That's true. So I should be shading this way. Right? If x is less than or equal to 9, then I have a vertical line right here, and it's a solid line, so I'm going to do a vertical line at 9 right here. And if I test my 0, 0 point there, x is 0 here, right? So I'm going to say that that's 0 is less than or equal to 9, and that's true. So I'm going to shade everything this direction, because I get to include the 0, 0, everything this direction with my vertical line. My solution is any place that I have a doubled over shaded area. So it's this wedge right here. All right, so I'll spend a little more time trying to figure out what the wording is and how we can write our inequality statements, and a little less time on what I do to actually graph these for the rest of the problems. Right, you want to build a rectangular playpen for your dog. You want it to be at least 10 feet, at least 10 feet. So can it equal 10 feet? Yes. So it could be 8 feet or 9 feet, or I'm sorry, it could be 10 feet. It has to be at least 10 feet. So can it be 9 feet? No, because 9 is not at least 10, right? So it can be 10, it can be 11, it can be 12, and so on. So we're getting bigger than 10, right? So we need it to be at least 10 feet, and it can be equal to as well. All right, so our width has to be at least 10 feet. So if we're thinking about 10, it has to be greater than 10, or it can be exactly 10. Okay, we have at most 50 feet long. So I can go as long as 50, right? So if my length is 50, that's okay, but at most 50. I can't be any more than 50. So I can be 49 and that works, but I cannot be 51. All right, so I have two pieces of information. I have my width, I have my length. I'm going to say that just to help me figure out what I'm putting on my coordinate plane, x is width, and I'm going to say y is length. So this is going to be x width, and this is going to be y length. All right, so what information do I have? I know that x has to be greater than or equal to 10. I know that y has to be less than or equal to 50. It can't be any more than that, but it could be exactly that. And I know that if I'm making this rectangular pen, it's like this, right? Rectangular pen, I have a length and I have a width. The whole perimeter of this, so 2 widths plus 2 lengths, right? 2 widths plus 2 lengths has something to do with 128 feet of fencing, right? So the perimeter has to be, if I have 128 feet of fencing, I can have my perimeter be exactly 128 feet, but it can't be any longer. I only have fencing to go up to 128 feet. Oops, sorry, you can't quite see that. I can't go over 128 feet because I don't have enough fencing if I go past that. Okay, I know perimeter is the same thing as 2 times the width plus 2 times the length. So what I'm going to do is kind of smush those guys together. 2 times the width plus 2 times the length has to be less than or equal 128, or else I'm going to run out of fencing. Okay, so this is my system. These 3 pieces of information. All right, so let's think about information that we want. If we want our length to be vertical, I have to be able to go, well, I'll tell you what. Let's go ahead and simplify this. And since I said width is x, I'm going to use the same variables because that's what we do with systems. So hang on, I'll fix that. You can watch me fix that. We said that x is width. So I just wanted to use all the same variables or I'll be confused. X is width. And we said length is y. Okay, so length is y. Now I have all the same variables. That's super much more helpful. I need to rearrange this inequality statement so that it looks like slope-intercept. So starting that out, it'll be 2y is less than or equal to negative 2x plus 128. So y is less than or equal to negative x plus 64. All right, so now I know that I'm going to kind of set up my scale over here. I'm going to go by tens in my length. 10, 20, 30, 40, 50, 60, 70, 80, 90, and 100, all the way up. Okay, and for my width, I'm just going to go by tens as well. 10, 20, 30, 40, 50, 90, 100. All right, let's go ahead and get our inequality boundary lines on here. X is greater than or equal to 10 is going to be a vertical line because that's a vux. So I'm going to have a vertical line right here at 10. It can equal 10, so I'm going to have a solid line. Okay, if my test point is 0, 0, then if 0 is in here, 0 is greater than or equal to 10, that means that I am shading not that test point. 0, 0 didn't work, so I have to shade in this direction. Because 0, 0 did not work. All right, so this guy is a Hoy line, right? I have Hoy is less than or equal to 50, so it's going to be a horizontal line. It is less than or equal to, so it's going to be a solid line. I'm going to use that same test point. Let's test 0, 0. So if I test 0, 0, then I have 0 is less than or equal to 50. That's true. Since that's true, I get to include 0, 0 when I shade here. So I'm shading below that line. Right now, my system solution would be right there, but let's see what happens with our third piece of information. Y is less than or equal to negative x plus 64. I'm right here, 64, so I'm just a little lower than halfway. And I have to come down 1 over 1. I'm going by tens here though, so I think I'm going to come down 10 over 10, down 10 over 10, down 10 over 10. That's easier, down 10 over 10. This is also going to be a solid line, and so I'm going to draw that solid line here. If you're nervous about coming down 10 over 10 and trying to estimate or approximate where that's going to be, you can always plug in some values that you're willing to work with. So I could always make like a t-chart here, and I could say if, I don't know, if x is 10, because there's 10, right? If x is 10, then y would have to be 54. And if x is 40, I'm just picking things I'm willing to work with, then y would have to be 24. So here's 10, 54, and here's 40 and 24. So you can always do a t-chart if you're not comfortable kind of guesstimating where those dots go. All right, I'm going to test. I'm going to test my 0, 0. I'm going to come up here and say test the ordered pair 0, 0. 0 plus 0 is less than or equal to 128. And so that means 0, 0 works also for this guy. So let's do that. Okay, so this is my double shaded wedge right here. This is my double shaded wedge. I've got 3 lines, a vertical, my diagonal that I just looked at, and I've got this horizontal line, and I have everything below it. So that wedge right there is going to be my solution inside here, this wedge. All right, Noah is buying pizza for a party. Pepperoni pizzas cost $9 each, and cheese pizzas cost $5 each. So Noah can spend as much as $45. He can spend 45, right? He cannot spend 46, right? So however much he spends, spending that amount has to be less than or equal to 45, right? Whatever he spends has to be less than or equal to 45. He can spend as much as 45, but not 46. Okay, and he needs at least 5 pizzas. So the number of pizzas he needs, it could be 5, at least 5. Could it be 4? No, it has to be greater than or equal to 5. All right, so we're going to write and graph a system of inequalities. And so I'm going to say, I've got information also about pepperoni pizzas and how much they cost, and cheese pizzas and how much they cost. So the question is, write and graph nope, no specific question. We're just going to write out the whole system solutions. Okay, I'm going to say X stands for my pepperoni pizzas. And I'm going to say Y stands for my cheese pizzas. Okay, so if X is pepperoni pizzas and Y is cheese pizzas, that's what it's going to look like on here. All right, so if I'm buying at least 5 pizzas, I'm going to assume that I can go by ones here. 5, 6, 7, 8, 9, 10. I'm going to assume that I can go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right. I have to buy at least 5 pizzas, and some are going to be pepperoni and some are going to be cheese, and I can spend up to $45. So what other information do I know? I know that for every pepperoni pizza I buy, it's going to be $9. 9 times every pepperoni pizza, plus how much is a cheese pizza? Cheese pizza's $5. $5 times every cheese pizza. This is the money stuff, okay? So whatever I buy, we already know the spending amount, the amount that I spend has to be less than or equal to 45. So that's what I know about spending money. And I know that the total number of pizzas I get, cheese or pepperoni, once I add them all together, pepperoni pizzas plus cheese pizzas, I have to have at least 5 pizzas. Okay, so now I've got these two inequality statements written, and I need to write them as slope-intercept form. So I'm going to do this first one, 9x plus 5y is less than or equal to 45. That's going to become 5y is less than or equal to negative 9x plus 45. Y is less than or equal to negative 9/5 x plus 9. Okay, and then my other inequality statement is easier. That's just y is greater than or equal to negative x plus 5. So we just have to graph them. Okay, so I'm going to graph this guy. I'm going to start at 9, and I need to figure out what my next ordered pair is. This time, because it's 9/5, I'm just going to make an xy table. Okay, I get to choose my x's and y's. I'm going to choose multiples of 5. So if x is 0, y is 9. That's this point right here, 0, 9. And if x is 5, then I have 0. Oh, I found my other intercept. 5, 0 right there. Okay, I know that it's got an equal sign included in the inequality statement, so this is going to be a straight line. All right, my test point for this guy, we're going to test 0, 0. 0 plus 0 is 0, so 0 is less than or equal to 45. That's true. So 0, 0 is part of that statement. Now I need to deal with y is greater than or equal to negative x plus 5. This one I don't mind graphing using the y-intercept and the slope, so I'm going to start at 5, and I have a slope of negative 1, so down 1 over 1, down 1 over 1. And so it's a slightly different line from what I had with the other guy. It is a solid line, so I'm going to draw that. I'm going to make sure that I show that I can do everything up to that line. Okay, so my pink line here, let's test 0, 0. Okay, so if I have 0 plus 0 is greater than or equal to 5, that's not true. So 0, 0 is not a solution for my pink line. So I'm not going to shade below it, I'm going to shade above it. So you can probably see my solution is everything inside this wedge here. So any of these ordered pairs would represent the combination of pepperoni and cheese pizzas that I could buy. Okie dokie. So if I look at making a fruit salad, apples cost $4 a pound, oranges cost $6 a pound, and I want to spend less than $30. Okay, so my spending amount has to be less than $30. It doesn't say that I can spend $30, it has to be less than $30, so $29.99 maybe. I need at least 4 pounds of fruit. All right, so now I have to decide. I'm going to say X is pounds of apples, and I'm going to say Y is pounds of oranges. So what else I'm buying? Yes, oranges. All right, so I know some things about the money, right? I know apples are $4 a pound, so I'm going to say $4 times every pound of apples I buy, plus my oranges are $6 a pound, $6 times every pound of oranges I get. I know the amount of money I can spend has to be less than $30. So there's my money, right? So my other statement is going to be about the total number of pounds I need, right? I need a total of 4 pounds. However many pounds of apples plus however many pounds of oranges, at least 4 pounds. So it can equal 4 pounds or it can be more than 4 pounds. So those are my two statements. I seem to have lost my graph on here. Let's see if it's on the next page. There it is. Sorry, I'm going to rip this apart. Oopsie daisy, my printing didn't do well. Okay, so ripping that apart because these are the things that go together. I have all kinds of information. I'm going to put apples on my x-axis because I said apples are x. And I'm going to say oranges are on my y-axis. And let's just count 1, 2. This is pounds of apples. 3, 4, 5, 6, and so on. 1, 2, 3, 4, 6, 7, 8, 9, 10, and so on. Okay, if I have x pounds of apples, I have y pounds of oranges, and I know x plus y is greater than or equal to 4. I'm going to rearrange my pink line. I don't know why I'm doing them out of order, but this is going to be y is greater than or equal to negative x plus 4. That's one line. And my other line, it would be 6y is less than negative 4x plus 30, which becomes y is less than negative 2/3 x plus 5. Okay, so I have two different boundary lines that I get to draw and then shade. Okay, my blue line here, I'm going to start at 5, and I'm going to come down to over 3. And so that is going to be a dashed line because I can't actually equal that. Okay, let's test 0, 0. So 0 is less than 30, that's true, so I get to include 0. So I'm going to say I'm shading this direction. My next one, y is greater than or equal to negative x plus 4. I'm going to start at 4, and I have a negative 1/1 slope. This is a solid line. Okay, and you know that if I were to continue on, there would be some intersecting point over here. I'm not sure it makes any sense because we're not really talking about negative pounds of apples or anything. Whoops, sorry about that. But in our scenario, we can use the double shaded, so we have to figure out, are we shading above that pink or below that pink? Let's check. I'm going to test 0, 0. And I will get 0 is greater than or equal to 4, and that is not true, so I do not include 0, 0. So I'm going in the other direction. Okay, and of course it continues all that way, right? Because that's all on the other side. But I know that where I'm double shading is my solution. So this wedge here is my set of possible ordered pairs that I could use. All right, thanks for watching.